Okay, so this guy is more of a either a calculator question or unit circle problem. I'm not going to require any work here. You should know where sine inverse square root 2 over 2 is. Let me open the circle. Give me one moment. I don't have it open anymore. Okay, there it is. Yeah, so we should you should know that the range of sine inverse will be on the right half of the circle, right? So this side. Now, sine inverse of square root 2 over 2. It will give you on the calculator 45 degrees, which is pi fourths, right? It will not give you the other solution, which is technically over here, right? There's two locations, but the inverse function will only give you values on this side for sine inverse. Okay. So that's all you really need to remember is more the concept. We should know it's going to be B. Okay. Is that clear? All right. Okay. Where's my calculator? Oh, here it is. So remember when I gave you all those domain and ranges for sine inverse and cosine inverse or arc cosine, whatever you want to call them. Okay. Sine inverse of square root 2, oops, over 2 is going to give me 45 degrees. Now, let's say I wanted the answer for negative square root 2 over 2. See how there's this location and then there's this location, right? It's going to give me negative 45 degrees. It's not going to give me 315, okay? Because it's defined on the right half of the circle. The range was from pi over 2 to negative pi over 2. So if I were to redo this, see how it gives me negative 45, which is really 315, right? Which we already knew because we saw the circle. That is the other location where it's negative square root 2 over 2. Right, 315. So it will only give you answers on this side of the circle. So it goes positive or negative, right? This way or that way. But if you punch it into your machine, it should give you the right answer. Just make sure that, what's it called? Understand that it's only going to give you the right half of the circle. Number 2, you literally just push that in. Nobody cares. Not a big deal. Just notice that they didn't say degrees anywhere. So the answer is 0.61. The only thing you need to be careful of is that 0.61 degrees or is that 0.61 radians? They didn't write a symbol, so we should be able to assume that it's radians. Notice how if I do it in, oops, I'm all blurry now. If I do it in degrees, obviously I'm not going to get the right answer. So you'd have to first know that, oh, okay, I had to switch and then redo it. See, 0.61 was the answer. So if you don't see any degree symbols, you should assume radians. Okay. The only pitfall here is make sure you know what mode is the answers. But for 1, 2, and 3, there's not real work to be shown here. So let's move on to this guy here. Here they want us to find an inverse function. So just like we did way back in college algebra, you'll do the same thing, but with a cosine. Okay. Let me write this question down, then we'll switch over. Well, I guess I gotta switch anyway. It's all good. Okay. So let's start. Actually writing stuff down here. Exam 1 or 2 review. Alrighty. So find, this is number, what number did we say it was? 4? 1, 2, 3, 4. Find the inverse function f inverse of the function f. So f of x is equal to 5x cosine plus 9. So step 1, we said change the f into change f of x into y. Excuse me. Step 2, swap x's and y's. Step 3, which is the main step, solve for y. Okay, so all right, so here we go. So isolate cosine is the first thing you got to do. So I'm going to subtract by 9, both sides, divide by 5. So that gives us cosine y equal to x minus 9 over 5. I put the cosine on the left just because I want to, not because it matters. Technically, cosine was on the right, equal to this, but you see how it doesn't matter, right? But at this point, you have to introduce arc cosine on both sides. That cancels your cosine. Now I have y solved for. Step 4 is just change the y into f inverse. Okay. Any steps that don't make sense? Do you see what we did and how we solve for y? All right. So not too bad, right? Okay. Number 5. It wants to solve for x. See, there's an inverse function. This one's not too bad. Okay, let me write it down. Find the exact solution. So for cosine inverse, x equal to pi. So isolate cosine inverse, divide both sides by 4. You get to here, right? Then do cosine on both sides to cancel the inverse. So x is equal to cosine of pi over 4 on your unit circle is √2 over 2. That's all there is to do there. The answer is B. Okay, let me switch this to degrees for the next question. Okay. Number 6. Find the exact value. So that's a hint that don't rely on the calculator. Just do it by hand with unit circle or whatever. Okay. So tangent, cosine inverse of -1/2. So what you can do, let me see here. Cosine inverse of -1/2. On your calculator, this is what you're gonna do. To cosine inverse, do the inside first, and you get 120. So this becomes tangent of 120 degrees. Tan of 120, well, look at your circle. Actually, let's do that part together. Look at the circle. 120 is right here. We know that it's y over x, right? So we should have square root 3 over 2 divided by -1/2. Right? The y divided by x, because that is tangent, y over x or sine over cosine. Okay, so here we are, divide them. This will become negative, positive divided by negative, square root 3 over 2 times 2 over 1, which is just negative root 3. So this would be your answer here. So far, 5 and 6 are they okay? See, that was A. Let's do this one. So that was number 6, 7. 7, I only want to do it because it's an interesting one. Notice how it's inverse cosecant. So we gotta take the reciprocal first. So cosecant inverse of a -2 is the same as sine inverse of 1/2. -half, sorry. Man, every time. Sorry, give me a second. Okay. Minus the cosecant -2 equals sine inverse of 1, -1/2. Look at your circle, or actually use your calculator. You're gonna get, let's see, sine inverse of -0.5, -30 degrees. -30 degrees or -pi/6, right? Same deal. So B. This one, number 8, will be very similar. So I'll leave that to you there. Okay. This one is interesting. Here we have to build a triangle, because notice how it's cosine and sine inverse. You can't just, it won't just cancel. You have to build your triangle. Okay, let's do that. Next page. Are you guys cool on that, on this first page? All right. So we're moving to number, what was it? It was 7, 8, 9. Okay. Write the trig. I'm going to shorten it up. Trig expression as an algebraic expression in U. Cosine of sine inverse of U. This will be rewritten. So basically, I think we did one of these in the notes. We said the easiest way to do this is to let theta equal the inside, sine inverse. And then remember that that means that sine theta is equal to U, right? If you take the sine on both sides, or if you use the definition, you can jump to here. Using this information, you can build your triangle. So here's theta, opposite is a u, over 1, there's always a 1 down there. Right, you write that better. Do your Pythagorean theorem. We're going to skip that step because we've done that quite a bit. 1 minus u squared. Yeah. So essentially, once you let this substitution happen, what they're really asking you to do is find cosine. Right? Cosine is adjacent over hypotenuse, which will be 1 minus u squared over 1. So this question is actually this. Is there any questions on those steps here? Okay. Let's move on to 10. Here they're telling us to solve on one period, 0 to 2 pi. So isolate sign, subtract 1. 1/2 minus 1 will be negative half. Both sides are negative, divided by negative gets us to here. Okay. So here's when we do the sine inverse of both sides. Even though we have the answers on the circle, let's go ahead and do it this way. So theta is equal to, I don't know, we did this earlier. (30°). But we said that there's two solutions whenever you do inverse. The second one is found by subtracting from 180. So we got 1, 2. But they have it in radians. So pi over 6 and 5 pi over 6. So just adjust using your circle or convert it yourself. Either way, answer will be C. Any questions on number 10? Move on to 12. Okay. Similar question. Solve I'm going to shorten it up here. 0 to 2 pi. Cosine squared theta minus 1 is equal to 0. So there's a couple of ways to do this. You could square root both sides, isolate cosine, or you could factor. Doesn't really matter. Let's do the square root just because. So we have cosine theta equal to plus or minus 1. So here we could just use the unit circle, right? 1 is cosine equal to 1 or negative 1. Looks like I think there's only 2 spots within 0 to 2 pi. Let's see. What is this? Thing? Okay. So cosine is equal to negative 1 here, right? Nowhere else. Cosine is equal to positive 1 right here. So the angle would be 0 degrees or 0 radians and pi. Which is right here. The theta that would do this for us will be 0 and pi. You could have also factored and done your inverse functions, but this one wasn't too bad. I'm gonna skip 13. That one's a weirdo one. I wouldn't recommend wasting your time on 13. I should probably delete it. One plus sine. So sine over 1 plus sine plus tangent. Okay. So the question is just telling you to simplify. No, we're not solving for anything. So whenever I see a tangent in fractions, I think, oh, maybe I can add these together. Let's see. Right, using our quotient or ratio property. Add the fractions, the LCD is going to be cosine, so introduce cosine here, introduce 1 plus sine over here. So this will be good. There we go. Cosine over cosine plus, then this guy will get 1 plus sine, 1 plus sine. Just to get our LCD going. The top will become cosine squared here over 1 plus sine cosine plus sine theta times 1 plus sine. I'm not going to multiply just yet. 1 plus sine times cosine. Okay. So the same denominator now. Just add the numerators. You'll get cosine squared theta plus, go ahead and distribute, I guess, sine plus sine squared. Let's skip the minor step there. Right, so we added the fractions. All of this was just adding fractions. And then I multiplied this here. you should see that cosine squared plus sine squared is equal to 1, right? So right here, we should get 1 plus sine over 1 plus sine cosine. I feel like we did this one before. These cancel. And you get 1 over cosine, which is secant. Okay, so I didn't write the properties this time. Here we did quotient. Here we just add fractions. Pythagorean made this 1 right here. And then reciprocal at the end. Okay. Any questions on any of those steps for number 14? All right, you guys cool on this page? All right, let me know. What number were we on? Just a 12, right? Oh. Okay, 15. Here we need to prove the identity. So you're gonna have one of these on the test. Something, I mean, not this exact same one, but same concept. Pick a side and make it to the other side. Prove they are equal. Okay. Tangent over secant theta minus 1. Secant theta minus 1 over tangent theta. They look almost the same. So I'm going to choose prove or establish identity. I'm going to pick the left side because I don't see anything really better. Both kind of suck. Okay. I do see. Currently, I'm not sure what to do, but we can separate the fraction and see what happens. I don't know. Where we said just try something, right? Hope it works out. Let's see here. Oh, hold on a second. Sorry about that. Okay. I don't see an easy way out of this one. So I'm thinking just change it to ratios and see what happens. Secant is 1 over cosine. Tangent is sine theta over cosine theta minus. This guy will just be cotangent or the same as, yeah, I guess we'll show that step. Right, we know that if we flip it over, that would be cotan. That's not going to be pretty. If we divide fractions, that's going to be 1 over cosine times cosine over sine minus cotangent, that would be cosine theta over sine theta using your ratios. All right, so these cancel, leaving you with 1 over sine. So I don't know why I wrote that out weird. Okay. It looks like this might work out, I think. So that canceled, gave me that, and though that guy's right there. So right now I'm here, 1 minus cosine over sine. That's not where I wanted to go. I'm thinking we may have to take a different path. Because now that I'm here, I realize that I need a conjugate. But I probably should have done the conjugate on step 1. So I say we start over. Take a different path. Because starting from here is going to be equally long, so it doesn't matter. Okay. Just erase. Okay, sorry about that. So what we're going to do, instead of that other idea, is multiply by the conjugate of the numerator. I see a secant minus 1. So if I do a secant plus 1, I'll force a difference of squares on top, which will give me secant squared minus 1. So multiply by the conjugate to get a difference of squares. Okay, So we're going to get secant squared theta minus 1. When you multiply out the top, you'll get this over, I'm not going to multiply the bottom, tan theta times secant theta plus 1. So there we go. That looks really ugly and it bothers me. Okay. Secant squared minus 1, remember, on your Pythagorean formulas, is going to be tangent squared theta. So this will become tan squared theta over tangent theta times secant theta plus 1, which cancels one of them, right? So now we got only one tangent on top, and secant theta plus 1. Okay. And that's where we want to go. Let's double check. Oh, yeah. Any questions on any of those steps? To this path was a lot shorter. Okay, let's move on to 17. Use the info given to find cosine 2 theta. So they give us this information. Cosecant is equal to 5/3, and they tell us that theta is between pi and pi over 2. So we need to know which quadrant that is. Which quadrant is that going to be? Okay. Pi over 2 is right here. So from pi over 2 to pi, that's quadrant 2. Okay. Cosecant is the same as 1 over sine, so that means that we can take the reciprocal, right, to get sine. Build your triangle. Put theta there if you want. Opposite will now be here and there. This will be 4. But quadrant 2 for the x value will be negative, meaning cosine is negative. Negative 4/5. All right. So now cosine 2 theta, use your formulas. I don't remember them. I think it was, yeah, could do this one. Cosine squared theta minus sine squared theta. There's cosine. There's sine. So that'll be 16/25 minus 9/25, which is, what is that? 7? 25. It's the ugliest sign I've ever written. That is probably pizza. See that orange dot? Okay. Any questions on 17? I know I went a little faster there, but any steps? Did it make sense? All right, let's do one last problem and I'll leave the rest to you. This is 18. Cosine 3 theta, cosine 2 theta. All you got to do is use your product to sum. That's going to be 1/2. So this is my alpha and beta. Formula says it's going to be cosine 1/2 times cosine of alpha plus beta. So 3 theta plus 2 theta plus cosine of 3 theta minus 2 theta. So that'll give me 1/2 cosine of 5 theta plus cosine of theta. And that's it. So you have one of these, so don't miss that question. Super easy. As long as you have your formulas ready, should not be too bad. I think the hardest one will probably be the proof question. You'll probably have only 1 or 2 of those. Okay. Remember, the review is very similar. So if you can do this pretty well without too many notes, then you should be good. All right. Dang it. You guys have any questions on the review that we just finished? All right, guys, let's take a 10-minute break. If you have any questions from your homework you want to do, or any questions that you're struggling with, we can do that after the break. Yeah, you'll be able to use similar as last time. So you can use unit circle plus a page front and back, whatever formula you like, or definition. Okay. No examples. So what I recommend is just all the formulas I've given you for chapter 7, just put them on one page. That should be more than enough. you want to add more to it, that's fine. But they're all in there. I write them down at the beginning of every section. All right, let's take a break for a bit. Let's say 20 minutes at 12:50. We'll see if you guys have any questions.